Hello and welcome everyone to today's cloud coaching session. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to show you an overview of the OCI Queue service and the basic differences between OCI Queues and OCI Streams. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OCI services and follow along with the demo today. To access the promo, please sign up using the same email that you registered with for the event. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Cloud Coaching North America that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there, you can search for the webinar channel. We'll also be checking the Zoom chat and the Zoom Q&A areas throughout the webinar, and we will open up for live Q&A after the demo concludes. Today's webcast will be presented by Senior Cloud Engineer Chinmay Thakar and Staff Cloud Engineer Sean Cartwright. So without further ado, I will hand it over to Chinmay.
Welcome everyone, and this is the agenda for today. We'll go through a quick overview of what the Oracle Queue Service is. I will go through the benefits of Oracle Queue Service, simple use cases in which Oracle Queue Services can be used. Then we'll go through a difference between queues and streams, or maybe a difference between different message brokers that are available in the market today. We'll do a quick demo of the OCI Queue Service as it looks from the console. We'll also go through a simple code that's written in Java to go ahead and put messages in the queue and get messages from the queue. And at the end, we'll go through the Code Innovate program overview. So starting up, what is the Queue Service? It's a new public service that's available on OCI. It's a fully managed and multi-tenant service. The main use case of OCI Queues is to decouple microservices and application software components. Queue actually comes in between producers that can push messages to the queue and consumers that can pull messages from the queue. And the queue service itself provides a very durable way of storing those messages. It has high throughput, it has low latency, and thus it makes it a really useful offering. The queue service provides it provides easy ways to decouple your applications and also enables asynchronous operations. The queue service is designed to support high scale, where throughput scales up and down automatically and transparently for the client. The next, we're going to go ahead and look at what makes the queue service powerful. The queue service actually gives you parallel processing. So you can have multiple producers producing messages into the queue, and then you can have multiple consumers as well consuming messages from the same queue. It also enables horizontal scalability, and this scalability is automatically done for you. And the queue service is also highly performant. Queue service is a fully managed service. And what does that mean? It automates all the infrastructure creation and the platform maintenance for you. So you just have to go ahead and spin up the service and everything in the backend is done for you. It patches all the softwares online so you don't have any downtime on the queue service. It tunes all the settings for you. It also diagnoses all the errors and manages that for you as well. The queue service is completely secure. You can go ahead and use IAM policies to secure who is going to go ahead and access the queue service. The data itself and the messages that you send in the queue, you can use custom encryption keys, and those keys encrypt the data both at rest as well as in motion. The queue service is auto scaling service, so it scales up and down as it is needed instantly. And this actually helps you with highest performance and the lowest cost that is required. The queue service is a pay-as-you-go service, like any other cloud services these days. It's a simple and minimal pricing dimension, and there is no additional cost for data transfer. It also is completely open source, so you can go ahead and use multiple protocols, may it be REST protocol or using OCI CLI. You can also go ahead and use various SDKs available. And it's also compliant with the STORM protocol, or it is the simple text-oriented messaging protocol. We're going to go ahead and look at a few benefits of the queue service now. And we go ahead and look at application decoupling. And what is application decoupling? So individual application components, when you go ahead and build an application, you want to go ahead and scale them up or scale them down based on the need. And whenever you scale up those components or any new application get built, they can go ahead and publish and subscribe or consume messages from the queue anytime. So the queue service sits over there as a service message broker, while your applications can scale up and down independently. It provides a reliable messaging processing. So a message that you put in the queue is never lost. So even if the consumer of the message is currently unavailable for consumption of that message, the message is actually persisted in the queue until it is actually deleted by someone or the message actually expires. It also offers buffer and batch operations. So when you go ahead and have some temporary bursts of data that are ingesting into that queue, it helps smooths that out for you, and it handles those temporary spikes in volume. And it also enables batch consumptions. It is auto-scaling, like I said. So whenever there is an unexpected traffic spike of messages coming within the queue, the resources are automatically added to handle those spikes and automatically degraded down when those spikes have been passed. It also ensures that a message that is put in the queue is at least delivered once. So we have at least once message delivery service. We also have a different kind of a service within the queue service called as the dead letter queue service. And what is the dead letter queue service? For example, a consumer is not available, or it goes ahead and consumes the messages, but it's not able to consume the messages correctly, or it is failing to consume the message. After a specific number of retries, the message itself is then put into a different queue, which is the dead letter queue. It helps you isolate some of those problematic messages that the consumer cannot consume, so that you can look at them and debug those messages going further. The OCI Queue is also technologically and vendor agnostic service. So looking at a few use cases of the OCI Queue service. So it provides application decoupling. So for example, if you see the first diagram, let's say the producer is nothing but a video service that's processing a video. The video is actually put into 3 different queues, and services that are supposed to work on the video, such as, let's say, encoding service, the resizing servicing, or compression service for the video, can consume those specific messages that are, or videos that are put in the queue and do their bit. So it helps with these individual components of an application to run independently by using the queue service. It also enables reliable message processing. So like I said, let's say the consumer isn't available and a message is put into the queue by the producer, the consumer is not able to get the message. The message is actually sent into the dead letter queue, and you can go ahead and debug those messages or see where the message is causing an error in your application. It also enables parallel processing. So you can have multiple producers producing within the queue, and you can also have multiple consumers reading out of the queue. So it also helps with, let's say, for example, a search ad engine, which accepts a high volume of data of ad requests coming in. You can process all of those requests with having multiple consumers reading out of a queue. The next thing I want to go ahead and look at is the different spectrum of choices that you have for message broker services. You first have distributed streaming. You also have message brokers. You have queues. You have streaming web services. And we want to look at when to use what service. So as you can see from the slide over here, the streaming service is a point-to-point brokered communication service. It's normally used for high throughput messages that are coming in, specifically, let's say, from IoT devices who sends lots of data. That's the process where OCI Streams can be used. A streaming service can be used. It actually does have order guarantees as well and message replayability as well. The second comes as message brokers, which also has point to multi-point communication. It's also a brokered communication service and has asynchronous semantics. It relaxes a little bit on the delivery guarantees. The next thing comes into the picture is our message queue services. It provides a point-to-point service. So a single message is only consumed by a single consumer for a specific period of time until the visibility timeout runs out. It is a brokered communication service and also provides asynchronous communication. It is a once only consumption service. So the message which is once read is then you can go ahead and delete that message from the queue. It also provides processing guarantees. It supports multiple protocols. It is auto scaling. And these are the different features that we already spoke about the OCI Queue service. The next thing that we come in is the web services, which is also a different point-to-point service, which provides direct communication and synchronous communication between two components. And it's a traditional messaging semantics that it's used. So it can be simple HTTP web services that can be used in this case. So looking a little bit more into the difference between queues and OCI streams, I want to go ahead and direct your attention to the specific link, and I'll open this link up. So I have this link up, which actually gives you a simple identification of which messaging service to use using different considerations that you can go ahead and use for that messaging service. I won't go through all the different considerations over here. So you can see there's orchestration, the payment, the bulk purchase methods. Oops. All right. I'm going to go directly to the decision matrix that you can see on the screen over here. And we definitely look at specifically the queue service, the second column and the third column over here. So as you can see, the queue service and the streaming service both provide choreography instead of orchestration. So the service itself works by itself. It actually looks for queues from other services to go ahead and push a message within, let's say, this specific queue service or a streaming service, or pull messages out of it. It doesn't do any kind of orchestration. The payment method in these is on the queue service, it's per API call, and it also adds the multiplier for every message that is above a specific size, which over here is 64 kilobytes. On the streaming side, it's the payment is per GB of data transfer plus the storage within the stream itself. So within a queue, how can you consume messages? So in a queue, there is only a single consumer. There are certain race conditions that are allowed, but normally there's only one consumer who can go ahead and consume the messages. While in the streaming service, there can be a single consumer, or you can have multiple consumers reading from the same stream. And that's where the partitioning part comes within the streaming service. So within a specific stream, you can have multiple partitions, and you can have multiple consumers reading from a single partition as well. The message retention after reading, so you do not have a message retention after reading in the queue service, while in the streaming service, the message is retained. Guaranteed order, so the order of messages that are coming into the queue service or the streaming service, there is best effort is guaranteed in the queue service, while within a specific partition within the streaming service, the order is guaranteed. Both provide asynchronous operations. Both also have input and output standards, which are supported by different open source APIs as well. So in the queue service, as you can see, it provides REST API and the Storm protocol, while in the queue service, in the streaming service, it has Kafka compatibility. So you can go ahead and use Kafka Connect or any Kafka compliant tool to go ahead and merge with the OCI streaming service. The maximum message rate in the queue service is 10 Mbps, while in the streaming service is 1 MB per second per partition. So you get up to 2, and you also have up to 250 GET requests per second in the streaming service. The message retention within specific queues and in streams, it's 7 days for both, but in the queue service, you can go down and shorten it if you like. The maximum retention in volume is 2 gigabytes per queue and 20 GB per OCI tenancy that you have, while the message retention is actually dictated by the number of write rates in the streaming service of 1 megabits, 1 MBs per second per partition for 7 days. Both go ahead and give you support for OCI SDKs and OCI CLI to go ahead and send messages. Both can have deployments in individual compartments, and you can go ahead and use role-based access using the OCI Identity Access Management Service to go ahead and limit the people who are going to go ahead and use both of those services. In terms of security, the data is actually encrypted in both of these services in flight and at rest. There is no message transformation that is done in both of these services. So messages that are coming in or produced by the consumer is the same that is consumed by the consumer. And you can go ahead and use logging in both of these services to go ahead and get a logging trail, an audit trail for the messages coming into these services. So this is a simple differentiation, and I encourage everyone on the call to go ahead and visit this specific link over here to identify the most appropriate messaging services for that specific application that you are currently building with using of OCI services that are provided. Now I'm going to go ahead and step directly into the demo itself. So I want to go ahead and quickly show you how the OCI Queue service looks within the OCI console. So when you go into queues, this is the screen that you'll get. It's a simple way to go ahead and create a new queue. You can just give it a name, and you can either go with the default configuration or you can go with the custom configuration. As you can see, the default configuration comes with a simple visibility timeout of 30 seconds. So what is the visibility timeout? It is the amount of time that a message is delivered to a consumer, and that specific message is not visible to any other consumers. So that consumer has a lock-in on that message, and it can go ahead and process that message for that specific period of time. No other consumers can go ahead and pick up the message in that specific time. The next is the maximum retention period. You can have, for here, the default configuration is 1 day. So this is the amount of time the message is actually retained before it is deleted from the queue service. The dead letter queue service is something that is automatically created for you and is free of charge. The maximum delivery attempts is the number of attempts that are tried to go ahead and let the consumer consume the message. If it goes beyond this specific attempts, the message is automatically put into the dead letter queue for you to debug that message and see what is wrong or why the consumer is not able to consume that message. And the encryption is Oracle managed keys, so Oracle is managing the encryption for you. So in the custom configuration, you can go ahead and set a few things over here, like you can set the visibility timeout, the maximum retention period, as well as the dead letter queue settings as well. So the dead letter queue settings involve the maximum delivery attempts, the attempts after which a message is put into the dead letter queue. So I already have a queue created for you. So let's go into the queue and see how it looks like. So this is the queue that I've created over here. It's a simple queue service created. There are no messages, as you can see currently within this queue. Over here, there is another dead letter queue, and there are no messages in the dead letter queue as well. As you can see over here, I have defined the visibility timeout to be 5 seconds, the maximum retention period to be 1 day, the delivery attempts to be 2. And you can also go ahead and have this message endpoint, which is going ahead and using this endpoint for REST APIs or also within your SDKs. You go ahead and send or get messages using this specific endpoint. So next thing I'm going to go ahead and do is quickly do a simple demo of putting a message in this queue. So let me go ahead and show you that as well. So over here, I have a simple Java code to put a message within the queue. As you can see over here, I have put the contents of the message as my first message. And let's go ahead and run this code to put a message within that queue service. As you can see, the message has been successfully put. So let's go back to our console. And as you can see over here, there is currently one visible message within the queue. And now from the console itself, you can go ahead and poll for these messages and you can see the message over here. I'm going to go ahead and change the poll settings and just say 2 seconds over here and save changes. And let's go ahead and poll for that specific message. All right, so the console actually polled the message for you, and over here you can see that the message that we put within this queue is now available over here. You can go ahead and find the message details as well, the size of the message, the receipt ID of the message. The receipt ID is something that is required if you want to programmatically go ahead and delete the message from the queue. You'll have to go ahead and provide the message receipt ID as well. So this is something that has been done for you. I also want to show you how a specific message, let's say, for example, the consumer is not available, and how the message is transferred to the dead letter queue service. So I have set the maximum delivery attempts to 2 over here. So currently you can see the delivery attempts are already set to 1. So every time I poll for new messages, the delivery attempts is incremental. So let's go ahead and do this a couple of times more. As you can see, I polled the messages for another 2 seconds and the delivery attempts have now changed to 2. It has reached the threshold of the maximum delivery attempt. So if I poll for messages one more time, this message is going to go ahead and move over to our dead letter queue. So now you can see there are no more visible messages, but the message has now been transferred to the dead letter queue because it exceeded the maximum delivery attempts. To view the message, you can just simply click here. And let's go ahead and change the settings. This is good. And let's poll for the messages in the dead letter queue service. So as you can see over here, the message will stay in the dead letter queue service for the maximum retention period that you have specified, after which it will be deleted. So the dead letter queue actually provides you a place where you can go ahead and see why the specific message wasn't consumed by the consumer correctly and debug this from your side. So let's go ahead and delete this message real quick. And let's go back to creating another message. So let's go ahead and change this to second. And let's run this message. So I'm going to go ahead and put in another message within this queue. As you can see, the message has now been available over here. Now I want to go ahead and get the message. So you want to go ahead and write a consumer code so you can go ahead and consume the message from this queue. All right. So as you can see, I've also written a different program to get messages from the queue. So when you go ahead and do a get call on these messages, you can go ahead and specifically mention the visibility over here, which I've sent to 10. And visibility is nothing but the amount of time the consumer blocks that message to go ahead and process that message. So I've set it to 10. There's also a timeout, which I've set to 7. And the limit of messages that I'm reading is something that you can set as well. All of these are optional criteria that you can go ahead and set. So let's go ahead and run this specific piece of code. So now you can see, I can see my message over here. So if you go back to the console, because I am currently reading the message, the visibility is currently 0. It is currently being consumed. But after 5 seconds, it pops back over here because the consumer hasn't consumed it. And it's back in this queue service and ready for another consumer to go ahead and consume that message. So the visibility timeout over here in 10 seconds is something that you can go ahead and set, which is required for a specific consumer to work on it. There's also multiple ways you can go ahead and update the visibility timeout of that specific message. So you have sample codes to go ahead and update the visibility timeout so that the consumer can block the message for a longer period of time if it requires more time to go ahead and process that message. Once the message has been consumed by the consumer can also go ahead and delete the message from the queue. So if I go ahead and poll for these messages again, as you can see, now the delivery attempts look two. So once the first delivery attempt was from the code when I go ahead and run the code to get the message, and secondly is from the poll messages over here itself. So this is a simple overview of how the queue service works, a simple demo of how you can go ahead and publish messages as a publisher into the queue and consume messages from the queue. There's also a way you can go ahead and send a message from within the console itself. As you can see over here, you can go ahead and say, hello world, a message body, and go ahead and send that message from within the queue as well. So now you can see there are two visible messages on the queue. When I go ahead and poll for these messages, you'll be able to see the messages. The other message was moved over to the DL queue because the maximum delivery attempts exceeded 2, and it goes ahead and goes into the dead letter queue right here. So this kind of concludes a simple demo of the OCI Queue service. I'm going to go ahead and stop sharing my screen and pass it on to Sean to give you a quick overview of the Code Innovate program.
Sure. Thanks, Chinmay. First and foremost, thank you everyone for attending today's cloud coaching session. I wanted to take the opportunity to talk to you today about a program that we offer here at Oracle called the Code Innovate program. So to explain our program, we liken it to an activity that our manager did with his kids most every year when they were younger. So he would take them on a trip to Legoland, which is just outside of Chicago. Out of all the attractions and activities at Legoland, their favorite thing to do was participate in the Lego Master Builder class. So during this class, all of the kids were given their own clear plastic bag of disassembled Lego pieces without any instructions, much like you would typically find in Lego sets that you buy in the stores for your own kids. So during this class, the adults in the front of the room, pictured here in green shirts, are known as true Lego Master Builders. So over the course of the event, they work with these kids on the concept of brick interlocking and how to create smooth faces on objects using Legos. So the output on this particular day was that they built these little penguins with earmuffs. So the goal of the class was first and foremost for these kids to have fun. However, in a short amount of time, they learned to build with Legos in ways that they may have never thought about before in a creative environment where they were allowed to try to learn new things. So in its simplest form, this is the essence of what we do here at the Code Innovate program. So we align our Oracle Cloud Master Builders, so to speak, to help your employees work with technologies in our cloud to create solutions in ways that they may have never thought about before, or that you just needed a guiding hand to get jump started. So what it is a 5-half-day online event on Zoom. The event centers around developing together. So this isn't Oracle building a solution for you and handing it off to you at the end of that cycle. We're going to be building it with you during the course of the week. So the goal is for our engineers to coach your employees in a collaborative way that demonstrates rapid knowledge transfer. So during this time, your team's going to brainstorm on the business challenges that you've brought to the table. You're going to identify tasks to complete, and we're going to work together to create a minimally viable product. So whether you guys are novices to OCI or if you're pros and getting a lot more comfortable using our platform, Code Innovate is all about building real solutions for your organization's most pressing use cases. And we take people with all skill sets across, the range from novice to pro. So how Code Innovate works. So number one, bring us your use cases and we can jointly determine if they are a good fit for our week-long sprint format. So we want to work on things that you guys want to work on. So by working with our team, you will, number one, get hands-on experience solving your own use cases with the coaching of our Oracle Cloud specialists. So Together, we will make a first pass at getting you on the fast track to solving your business challenges and getting you upskilled at the same time. So bring your use cases. We're going to be coaching you along the way. And hopefully by the end of the week, you guys are going to have something tangible in hand, a first pass prototype. So what are the requirements? So the requirements are 3 or more developers or builders at the event. So we use the term developers loosely. They can be business users, business analysts, anyone, some HR departments. So anyone who's comfortable learning how to build an OCI and that their skill sets fit the use case itself. So anyone who wants to build in the cloud is welcome. So it's a 20-hour time commitment, which translates to 5 half days. So bring your use cases. Again, we want to work on things that you guys find of high value to your business and things that you need to solve. We just ask for at least 3 weeks of lead time. That ensures that we get the correct resourcing on our side, that you have the correct resourcing on your side, that everyone is available and ready to engage and can be, focused, hands-on, heads down for that half week long event, rather. For 4 hours for 5 days, 20 hours in total. And last but not least, there's no fee to do the event beyond the time commitment for both of our teams and the cost of the cloud services that you guys consume to build out the use case. So if you guys are interested right now, please go ahead and chat in your email address and we can, get something started. Or if you guys want to take this away and think about it and get with your team, and you can find us at the Code Innovate _US_GRP at oracle.com email address. Just send us a message and we can take it from there. So I really appreciate everyone coming today. It was nice to speak with you. My name is Sean Cartwright. I'm one of the program managers here at Code Innovate. Thank you.